Hello, everybody. It's Professor Rehse coming to you again. I'm speaking to you today from the University of Windsor main campus in beautiful Windsor, Ontario, Canada. And I am absolutely thrilled to be talking to you all again today. I'm joining you in honor of our second virtual Great Lakes Region and Tribal Nations summer camp session. You've heard a lot of interesting talks, and I'm going to be talking to you something today that we haven't talked about before, which is careers in science and what you might be thinking about if you're so excited by all this great STEM content you've been getting in all of our summer camp sessions that you're really thinking a career in science is for you. Well, how do you know what kind of scientist you want to be? That's what I want to talk about with you guys today. So let's go ahead and jump right into it. Let me share my screen here. Here it comes. All right, so the question is just this. Say you're thinking that a career in science is something you want to do. Well, what kind of scientist do you want to be? Let's go ahead and talk about that. So, just a word about myself. From 2005 to 2011, I was a professor of physics at Wayne State University, right across the river from where I'm located right now. And from 2011 to 2019, I've been here at the University of Windsor, nestled right into the banks of the beautiful Detroit River, sharing its space with the great city of Detroit. So I've been a physicist, a professional scientist, a professor for almost all of my professional career. And it's a fantastic career. Maybe it's something you would want to be interested in as well. But the reason I shared that map with you is because this series is co-sponsored by Wayne State University, and I'm coming to you from the University of Windsor. We share that border between the two of us, nestled in there along the Detroit River, that it's really important we acknowledge this land that we sit on that's given us the opportunity to do our science and to give me the career that I've had. So the University of Windsor sits right there on the traditional territory of the Three Fires Confederacy of the First Nations, which includes the Ojibwa, the Ottawa, and the Potawatomi. So we respect the longstanding relationships with the First Nations people in this place, the 100-mile Windsor-Essex Peninsula and the Straits or Les Deux of Detroit, a beautiful location to be, and we're very lucky and honored to be here. So we are here to talk about STEM, right? We even call this the Great Lakes Region and Tribal Nations STEM summer camp. So we've been talking a lot about STEM, but have we really defined what STEM is? I haven't actually heard that defined yet. So let's go ahead and do that. Let's make sure we all understand exactly what we're talking about. STEM is an acronym. So it stands for science, technology, engineering, and math or mathematics, STEM. So we are super excited, and we hope that you all are considering careers and lives in STEM, which would be any one of the thousands of fields which fall under this umbrella of working with science, technology, engineering, math in some way. So you're all here to learn about STEM, and you love STEM, and you're excited to talk about STEM. But has anybody ever explained why we're here to talk to you about STEM? Why is it that so many professionals, week after week, month after month, are volunteering and donating their time to talk to you all about their life in STEM and to spend their time to try to get you excited about a life in STEM as well? So why is it that so many people are willing to do that? Have you talked about why? Well, let's talk about that for 1 second. So to motivate this, I want you to think for yourself. So what are our two countries? So I'm in Canada, and you might be listening from the United States. So what are our two countries' most valuable resources? So if I just ask you, what is the most valuable resource that our two countries have? What would you say? Maybe you say, oh, it's gold, all the gold piled up in Fort Knox. It must be all the gold that we have. No, I don't think so. Then you say, well, okay, well, maybe it's energy, right? All the oil that we need and the natural gas that we need to power things. So it's that kind of resource. I don't think it's that either. And you say, okay, well, maybe it's the abundance of clean water we have, the abundance of clean air that we're blessed to live with. And that must be our most valuable resource. It's valuable for sure, but I don't think it's our most valuable resource. So what on earth could it be? What is our most valuable resource? It's you. And I bet you weren't thinking that. It is you, the people listening to my voice right now, thinking about STEM, getting excited about science and technology. You are the most valuable resource that we have. Your minds, your curiosity, your creativity, your passion for learning. This is absolutely the most precious resource a nation possesses. More important than gold or oil or water is you. It's the human resource. Okay, you are the engines that drive this nation forward. It's the abilities of the people, and you are the next generation of people that are going to be driving us forward. There is no resource more precious to any country than the minds of its youth. And so it's really important what we're doing here today. Why is that so important? Why is it that you're the most precious resource? Well, it's going to be your ability to become the next generation of thinkers and leaders, and the next generation of the generators of wealth, strength, security, stability that we all rely on. You are so lucky. We're all so lucky to be living in these great nations that provide for us and are peaceful and seem to work so well. But we need every generation to reinvent that and to create it again and to push it forward and to make it better. And that's going to be you. It has to be you. There won't be anyone else around to do it for you. So even with all the natural resources we have, without your ability to do something with it, to do something productive with it, to do something responsible with it, they mean nothing. You're the most important resource that we have. There is no doubt in my mind. And so for those of us at this camp, now that we've identified that your abilities and your intrinsic talents are the most important resource that a nation has, we believe that STEM, science, technology, engineering, math is the best way to secure that future. There are plenty of great careers, of course, and they can be wonderful and very rewarding. But in terms of advancing us as a nation, as a people, providing wealth and stability and security for everyone, STEM is the best way forward to secure that future. So it's critical. It's not just, oh, that's interesting and fun. This is critical to the success of our nations and our futures and our livelihoods. So all of us on the call, we think it's really, really, really important that we develop you to take our place as we become older and move out of the fields. All right, we found wonderful careers and lives that we love. We want you to be the next people to have that exact same opportunity. So it's absolutely critically important. And I know everyone at this camp believes that for sure. So basically, we need the best and the brightest of all of our youth, and that's you all. If you're watching this video right now, almost assuredly you are amongst the best and the brightest of the people who are out there, because you're already showing this intrinsic interest in science and math. So we need you to go into the STEM fields. And we hope that by showing you how fun and exciting it can be, you will actually consider that as a career move for you. So we hope that you choose to go into science. And of course, STEM, right? Technology, engineering, math. Now, I'm a scientist, so let's just stick on the S part of it. But of course, these discussions hold true for all of those fields as well. But let's assume you want to be a scientist, because that's what I am. That's what I can speak about. What kind of scientist would you be if you do chose to go into science? Lot to think about there. There's so many fields, and you probably don't even know about a lot of them. So let's talk about those fields. Okay, first thing I want to do is, if you imagine yourself as a scientist, you might have some thought picture in your mind, but it's really important that you don't get locked into one way of thinking about scientists. So here I have two pictures of scientists, and I've called this what most scientists do not look like. All right, so when people think of scientists, they kind of think of, yeah, it's a person. They're definitely wearing a white coat, and they've got their rubber gloves on, and they've got safety glasses, and look, they're pipetting some things inside a fume hood. And again, here you go, nice sterile white gray lab with lots of glass and, you know, microscopes and lab coats and gloves and little test tubes, vials, and things like that. That's what people kind of think of with scientists. Most scientists do not look like that. So if you're thinking of this and you're like, nah, that's not for me, that's okay, because most people, when they practice science, don't do it in that way. And that's kind of what I want to talk about today. Now, to be fair, some people do practice science that looks like that. So there's this field called biology, and there's a career called like cellular biologist. So this is my good friend and colleague, Dr. Lisa Porter. She's a very successful cellular biologist, and this is a picture of her, and this is in one of her labs that she runs here at the University of Windsor. And yeah, you can see they wear white lab coats to keep themselves safe in the lab, and lots of chemicals and reagents, supplies on the back, and gloves and things like that. So they work in labs, and you know, they're trying to understand what causes cancer. centers in human cells, and that's a very important job. So if that's the kind of career you want, science is absolutely the place for you. It's a fantastic job. But most people, most scientists don't, even in biology. So let me just contrast Dr. Lisa Porter with another friend and colleague of mine. So this is Dr. Dan Mennel. Dr. Dan Mennel studies wildlife, so he would be a zoologist. In particular, he's an ornithologist. He studies birds. So here he is with an apparatus that he's using to actually listen for and record bird calls. Right? So Dr. Mennel has to go out into the woods, far off places, and he tries to record bird songs because he wants to understand how it is that little baby birds learn to sing all those songs. And here are some of Dr. Mennel's students, and they're out in the woods, and you can see there's no white lab coats or rubber gloves anywhere. They're way out in the middle of the forest, long pants, hiking boots. They have to take boats to get to this island where they do studies on. And so if you love being outdoors and out in the woods, this would be a great career for you. How about geology? So it's another type of science. So I'm going to just run through the different types of sciences that there are, and then the different careers that could be within them. So geology. So everybody's fascinated by volcanoes and natural disasters. Well, there are classes of scientists, of geologists who study volcanoes, and they're called volcanologists. So here is a volcanologist in his protective suit. You can see he's right up on the crater of a volcano. It's blowing up behind him. That's no white lab coats anywhere in view. As a matter of fact, this is a very dangerous job because he's got to hike up to the edge of the volcano to study what's going on in there. Or how about just a field geologist? So here's a field geologist. You can see he's way out in the boondocks, right? And he's making some kind of, he's getting some measurements off this rock structure formation here. And they're trying to understand where do these rock structures come from and what happened in the ancient past and what is it telling us going to happen in the future, right? So a very outdoor type of lifestyle for that type of geologist. Physicists don't always wear white lab coats and work in bench. That's what at a lab bench. That's what I am. So here's a picture of Sally Ride. Sally Ride was the first American woman in space. She's an astronaut. She was a physics major, right? So she started her preparation with a science degree in physics, and of course she got to go to space with that type of science degree. Maybe you want to go to space too. Physics would be a great way to start with that. Here's another physicist. He's not wearing a white coat because he's wearing a huge parka coat. He's actually down at the South Pole. So there's a whole bunch of physicists who go down to the farthest places on Earth, the North Pole, in this case, the South Pole, because they're studying very strange particles that arrive from outer space. And down at the South Pole, things get trapped in the ice and they can study them there, free from a lot of the other effects of human life on Earth. And you know, it's never warm there. So look how bundled up he is and how that's like an adventure just to get there. So they don't work in a lab. Their lab's down and out in the remote South Pole. And what an exciting kind of a adventurous career that would be. So again, most people don't think of physicists as doing things like that, but absolutely they do. How about forensic science? So maybe you're like, you kind of want to be a police officer, a peace officer, or something like that. Well, science has a role to play. Of course, the show CSI, the crime scene investigators, that's a great career. We have a Department of Forensic Science here at the University of Windsor in the Faculty of Science. And these are people that are scientists, but they're kind of crime solvers too. So you have to go into the field. So here's a fellow who's dusting for fingerprints, obviously on the side of a door. They're trying to see what trace evidence was left behind by a suspect. Here's a scientist back at his lab, presumably, and he's trying to chase the trajectory of bullet holes through this door panel. So they use science to solve crimes, right? So a really interesting field that directly impacts the lives of the people around you, a very relevant type of career choice that could be very, very rewarding and really important. Computer science, right? So some people just love playing around on their computers. Well, computer science is a very lucrative career choice right now. There are so many careers you can go into with computer science. You can be a network analyst, right? So if you're watching me right now, we're communicating through some type of internet network. And that internet network is kind of maintained, run, improved all the time by network analysts who keep an eye on this. Cybersecurity is a huge one, right? If you are interested in computers and you are at all interested in cybersecurity, this is such an important field. We really need our best and our brightest minds now to go into cybersecurity to keep all of our nation safe, to keep your banking information safe, to keep our critical infrastructure from being attacked. All right. So it's being attacked constantly by very, very smart people. And we need even smarter people. That's you, who are really good at computers and passionate about it and really want to figure out puzzles. And you don't like it when people get the better of you, to become cybersecurity experts, to keep all the rest of us safe. We rely on you. You are our frontline defense now in this digital world. It's so critical. And I don't think people think that way, but it's really, really important. If you go into those fields, all of us would be really, really appreciative of it. Mathematics, right? People love mathematics, but I don't think most people know what mathematicians do. The answer I usually get when I talk to the Department of Mathematics and Statistics here at the University of Windsor, and people say, what do mathematicians do? The answer is, what don't mathematicians do? Because they're involved in almost every field. Every field and industry that is making money is probably hiring mathematicians, because they're so keen on maximizing income in very, very slim profit margins, and mathematicians are really good at being able to model markets. So financial analysts is a big career for mathematicians, where they're trying to understand just finance, how it works at the level of a company, all the way up to the level of huge stock investment firms, to try to model the stock exchange and to try to figure out what the market is doing. Actuaries are people who are really good at math, and they work for insurance companies and banks, and they try to calculate what's going to happen in the future. They calculate risk, and they use probability theory to try to optimize the way what people spend on, say, life insurance and things like that. So there are just so many fields that mathematicians are involved in that you wouldn't think, oh, it's not like a mathematics company. That's just not where they work. They just go to work for every other place, and it's really valuable career and really in demand. Chemistry, of course, some do. So again, when we talked about, do people wear white lab coats and wear gloves? Some people do, for sure. Some chemists do, not all, but some do. So there's a job called analytical chemist. So here are some people, and they're taking purity standards. So the analytical chemists, this is a picture from the USDA. There's so many chemists that are always trying to do quality assurance for companies, or they work for the governments, checking for the purity of chemicals, water, clean air, clean water, clean soil. Every product that you buy in the store that you consume or put on your face or whatever, they have analytical chemists working for those companies to test their purity, guaranteed. Toxicologist is a cool career. So these are people that are just looking for, when any kind of clinical sample, are there trace amounts of any foreign chemical that shouldn't be there? So a really exciting career in being able to detect very trace amounts of improper chemicals that shouldn't be in samples. That could be a fantastic career. Environmental science is a great one. I love to throw in this slide, because this actually is a slide, again, some peers and colleagues of mine. This actually is my dean. So the dean of the Faculty of Science, Dr. Chris Hauser, and he loves this picture because, sure, he's a dean and he runs all the scientists here at the University of Windsor, but he would much rather be doing the science that he loves to do. So here he is on the beach. So Dr. Hauser is a world expert on riptides, so currents that kind of flow from the beach outward into the ocean. And in some parts of the world, many people a year drown in these very powerful currents that flow outwards, and people get taken away from them. So he travels all over the world, and he loves to go to countries like Costa Rica where these things happen, and he studies on the beach. So here Dr. Hauser is with his students doing the type of teaching that he loves best. Being in the field, showing the students what exactly is happening with these rip currents, and they have to go to these places to make these measurements. And then again, here's my colleague, Dr. Aaron Fisk. He's out on one of his boats in the Great Lakes. So he's a very successful scientist at our Great Lakes Institute for Environmental Research, where they study the health of fish in the Great Lakes. And this is a really important question, because so many lives and jobs and our economies depend on the health of the Great Lakes, and we need really good scientists to study what's going on in those waters. No white lab coats anywhere in sight in these pictures. There are 1,000 more jobs, right? I just gave you a bunch right there. I couldn't possibly list them all. Thousands of jobs in science, right? Again, you want to go look for dinosaur bones out in the field. You can absolutely do that. Here's a physicist at the Large Hadron Collider. He's running an experiment in the detector of this collider in Switzerland. So he looks kind of like a cave diving spelunker, but also kind of like an industrial worker. Well, that's a physicist at work. Here's someone taking measurements. Looks like he's injecting something into a shark, a marine biologist. You want to go scuba dive and go underwater and study the sharks? That's a scientist. You want to go into the field and make measurements of seismic activity like these scientists are doing. Yeah, you could do something like that. So there's so many thousands of jobs in science. So don't be so limited into what you think a career in science or technology or mathematics could look like, because they really look like a lot of different things. And it just, whatever you're interested in, however, whatever you think is fascinating, there are jobs in science studying that. There really are. Now, I do want to say that there are two things that all those people have in common. So you think, wow, the guy in the volcanology suit, and the person at the South Pole, and the person on the beach, it doesn't look like they have anything in common, but they are all scientists. They will all have two things in common. Number one, because they're scientists, they're all very curious, and they're constantly wondering how the world works, and they never stop asking questions, just like you all. Questions are good, especially when you're young and you're just starting to learn things. You have questions. It's okay to ask questions and to want answers to them. Scientists are always asking questions. We're asking, why does it act that way? Why does that happen? How does that happen? How can it do it? How can we stop that from happening? How can we make that happen faster? It's all about questions, right? So scientists, we don't just sit around and read books, which is facts. And I hope you don't have science classes that are just kind of boring. You read things and you just read lists of facts. That's not what science is at all. Science is not about facts. Science is about questions. We always have questions. If we knew everything, it wouldn't be science. We'd just be studying something that's already known. It'd be like history. Scientists love to ask questions. We love it when we don't know what's going on, because that's our opportunity to try to figure something new out. It's a really exciting life. Number two, when they have those questions, how do you answer that question? Well, they're going to use what we call the scientific method to answer those questions. All right, so two things in common. One, we have questions, but two, we will use a standardized method to get answers to those questions. So what is the scientific method? Well, it means we don't dive onto Google, click, 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 to try to figure out what the answer is. You don't just guess something or make it up. Well, I guess it's just that happening. That's not the scientific method. It's not supernatural causes, right? We don't just make some appeal. It's like, well, something's happening that we have no idea what it is, but it's something supernatural making it happen. No, that doesn't work either. We're going to come by our answers in a very systematic way. We are going to ask careful questions, well-posed questions that frame the phenomenon very well. We are then going to perform or build some careful experiments or careful analyses or very well-crafted models that describe the phenomenon to see if that explains what we're seeing. We're going to try to poke holes in our own theories or explanations. That's a big advantage that science has. People think that scientific theories are set in stone. They're not set in stone. We're actually trying to attack them all the time, right? Because the only way something gets stronger is if you're constantly pounding away at it to reveal its weaknesses. So the things that we come to believe as scientific theories are there because we've torn away all the weak and models or theories that don't actually work very well. We look for fundamental principles that explain phenomena. We try to believe that because all science is it's going the way the natural universe wants it to work, and it probably operates under some simpler fundamental principles and not really hyper complex observations that we see. We will then propose new experiments to test our hypothesis. So once you've seen something, you explain it, you say, okay, if I really understand that, and if this is the truth, then I think we should see this if you look here. And you make a prediction. So science has predictive power. It's not just descriptive of what happened in the past. It says, okay, I understand in the past, I understand the fundamental principles that cause that. Therefore, I can tell you this should be happening if my theory is consistent. You make a prediction, you tell people to find it before it's ever been seen before. That's how we verify scientific theories in science. And then we ask others to do the same thing to see if they get the same answers. We don't hoard our knowledge and say, I'm the only person who understands this. No, when we have a great theory, we put it out there. We publish things. That's why we have all these papers and all these journals. We put all of our information out there and we say, hey, I think I'm right. Here it is for everybody. You see if I'm right too. Do it yourself. See if you agree with me. See if you can poke some holes in my theory. So it's a very kind of competitive yet collaborative environment where only the best and probably correct answers rise to the top. It is the best way to answer those questions. That is the scientific method. So we're here to talk about STEM, and now you know why. That's what I've been trying to get across. Our future way of life, all of us, yours and mine, our healthiness, our happiness, our prosperity, it depends upon you and thousands more like you, thousands of intelligent, curious, dedicated, and passionate youth who are going to get excited by STEM. You want to study it now. You want to study it for the rest of your life. You're going to choose an exciting and rewarding life involved in one of these STEM fields. It's absolutely critical to us, absolutely critical. And we really hope you do consider some fields like that. So with that, I will thank you, and I'll leave you with a very big thank you from myself and my group of physicists. Here they are, standing outside. Beautiful day at the University of Windsor. These are all young physicists ready to embark upon their own careers in the STEM field. So I hope that's inspired some of you. I hope you give this some thought. I hope you decide to choose a career in one of the STEM fields. All right, thank you so much, everybody. I really appreciated talking with you. That was some food for thought. I hope that means something to you. I'll talk to you again in the near future. Bye.